For many, many, many years, mathematicians were puzzled by the square root of negative numbers. Now, puzzle is probably the wrong word. They just basically said that the square roots of negative numbers didn't exist, period, and just threw their hands up and went on about their way. Now, the reason for that is simple. If I think of the square root of something like 4, I'm basically asking what number would I multiply by itself to get 4. 2 works, and negative 2 works. So when this symbol was adopted, it basically meant the principal square root, which means I want the main one. So that's why when we write the square root of 4, we write 2 and not plus or minus 2, because this symbol means principal root. So there are two options there, even though we choose by this symbol to go with only one of them. With negative numbers, though, it's impossible when you think about the regular numbers that we have, because a positive times a positive is a positive. A negative times a negative is positive. So what number can you multiply by itself to get a negative? And people were like, nothing. So there's no real answer. So up until this point, you probably wrote no real solution when you solved this problem. Now, in the 1500s, a couple of mathematicians came along, and there were a couple of applications that they were talking about dealing with what's called optics, which is an application in physics about how light operates. Where they found the need to sort of describe what's happening with the square root of negative numbers, even if they didn't actually find a value. So there's a clever little trick that mathematicians used here. Basically, they said the problem isn't negative 4, negative 54, negative 132, it's the negative itself. If I took that negative out of the way, then I could just simplify the square root and say something about its value. So what mathematicians do now is they say, hey, negative 4 is negative 1 times 4. And I can use that rule that we talked about in simplifying square roots, where the square root of a product can be broken up into a product of square roots. Now, square root of 4, I can simplify. No big deal. That's 2. But the square root of negative 1, I don't know what that is. That's kind of like something that's not real. So a mathematician named Girolamo Cardano sort of worked with this, and then a mathematician named Euler gave it its name. He basically said, let's take this square root of negative 1 and give it a name. Let's call it I. Now, it's funny because this is called the imaginary unit. Kind of like 1 is the unit of our number system. This is the unit of these imaginary numbers. And the word imaginary wasn't even Euler's like creation. It was people who were making fun of this. They said, oh, you're dealing with these imaginary numbers. But it's stuck. So we would basically say this is 2i. It's 2 times that square root of negative 1. So anytime you're taking the square root of a negative number, you essentially want to pull out that negative, replace that square root of negative 1 with that imaginary unit, I, and then simplify the rest of the square root. And leaving that in terms of I is perfectly fine. So again, I'm going to pull out the negative 1 by taking square root of negative 1 as I. I'm going to factor the stuff that's left. So let's see, that looks like 2 times 66, 3 times 11, ooh, ha ha ha, times 2, because it's 6. So I have a pair of 2's, which is a 4, so I can pull a 2 out, and the 3 and the 11 can't be broken up anymore. So this is 2i times the square root of 33. So when you have a square root of a negative number, deal with the negative by using the imaginary unit, I, and then simplify the rest of the square root.